Hi guys, today we are going to talk about asynchronous transfer mode. Well, asynchronous transfer mode, abbreviated ATM, like the frame relay, is a very high-speed packet switch service that is offered by a number of communication companies. The transfer rate as fast as 622 megabits per second, with even faster speeds possible in some locations. Now and hence we are just going to refer to it as AMT. So AMT has several unique features that set it apart from frame relays and other packet services. The first one is, in AMT all data is sent in small packets of 53 bytes called cells. The cell size is kept small so that when a cell reaches a node or a switch point in an ATM network, the cell will quickly pass through the node and continue on its way to its destination. This fast switching capability gives ATM its high transfer rates. ATM is a fully switched network. As the cells hop from node to node through the network, each one is processed and forwarded by high-speed switches. And the third property is, ATM networks were designed to simultaneously support voice, video, and data. For this reason, it can handle a wider range of applications compared to frame relays and the other methods. Now, as in frame relays, before ATM can transfer any data, you must first create a logical connection called a virtual channel connection, VCC. Unlike frame relays virtual connection, however, this VCC must be created over a virtual path connection. So in this case, we don't really use cables like in the frame relays. A virtual path connection, VPC, is a bundle of VCCs that handle the same endpoint. VCCs are established for data transfer, but they are also established for control signaling, network management, and routing. Now, a VCC can also be established between an end user and a network entity. VCCs can also be established between two network entities, not only between network entities and end users. When a VCC is transmitted from between user and network, the connection is called user network interface. When it's transmitted between two networks, it's called network interface. Now, we are going to look at the classes of ATM services. One of the features that sets ATM apart from most of the other data and voice transmission systems is that it provides users with ability to specify a class of service. As we can see in the frame relays and in the other services, the network providing services, you cannot specify classes. But with ATM, we have the luxury of specifying the class of the service we want. Now, what is a service or a class service, or a service of a class of a service? A class of a service is a definition of the type of traffic and the underlying technologies that will support the type of traffic. For example, the real-time interactive class of service defines video traffic. If a network does not provide varying classes of service levels, then all applications share the network bandwidth equally, which may not provide a fair distribution of bandwidth. For example, imagine you're trying to send an email within the same cell as a friend or a co-worker who at that same time is trying to have a video conference with someone who's out of the network in, say, another city. Now, it is clear that him doing the video conferences is a priority. It should be a priority within the network. But if you're using frame relays and the classes are not defined, your network, within that same network, if he sends an email and then if you send an email and your friend is trying to have the video conference at the same time, the network will be shared into two. It means, but the email, you sending an email doesn't require as much bandwidth as video conferencing, but the network doesn't understand this. So it assigns to you the same amount of bandwidth as him. So your email will go, although the email is not that urgent, it's not a priority in this transfer, but it will try to transfer your email at the same time as he is trying to have his video conferencing. So his connection will be affected because he needs more space, and the system is not intelligent enough to realize that the email doesn't require half of the bandwidth of the network. But if you're using ATM communication system, the system it gives you the opportunity to choose a class. So in this class, you can specify that the emails are of less priority than the video conferencing. So when the network is assigning the bandwidth, it assigns more bandwidth to the video conferencing and very small one for the email, which is very suitable for a network, generally speaking. Now this is like a general overview of an ATM cell. We have 4 bits for generic flow, 8 bits for virtual path identifier, 16 bits for the virtual channel identifier, 3 bits for the payload type, 1 bit for the cell loss priority, 8 bits for the header error control, and then we have data. The data can vary, but here we have 48 bit. For ATM it is 48 bits. So overall a cell of an ATM transmission is 38 bits for each individual field. Now ATM has defined 4 classes of service. Like we're talking about the classes of services ATM offers. 4 classes of service that are functionally equivalent to lease line service, frame relay, and internet services. Now the first one is constant bit rate, CBR, similar to current telephone system lease line. CBR is the most expensive class of service. The second one is variable bit rate, VBR, similar to frame relays service. RT-VBR is used for real-time applications such as compressed interactive video, and NRT-VBR is used for non-real-time applications such as sending email with large or multimedia attachment. The third one is available bit rate, ABR. ABR is also used for traffic that may experience burst of data called burst traffic and whose bandwidth range is roughly known, such as that of a corporate collection of lease line. The fourth one is unspecified bit rate, UBR. UBR is also capable of sending traffic that may experience burst of data, but there are no promises as to when the data may be sent, and if there are congestion problems, there is no congestion feedback, as it is the case for ABR. Now, by offering different classes of services, the ATM service provider can also offer tailor-made transmission services and charge the customer accordingly. Also, the customer can request a particular class of service that is appropriate for a particular application. Now, these are the advantages of ATM over the other communication methods or data transmission methods. ATM can support a wide range of applications with varying bandwidths at a wide range of transmission speeds. Cell switching, which is performed by ATM's high-speed, hardware-based switching that routes cells down the appropriate path, is so fast that it provides short delays and high bandwidth. ATM's different classes of services allow customers to choose service type. As we mentioned, with the problem of sending an email and someone else within the same network trying to video conference. So choosing a service type is an advantage, and pricing individuals for each data connection. So you can specify the class and then the type of connection you want, and then you have to pay accordingly. ATM is extremely versatile. This means it can carry voice, packet data, and video at the same time. Now, these are the disadvantages of ATM. it is often more expensive than the other data transmission options. Obviously, I mean, with all the facilities and the features that it provides, it's just very obvious that it has to cost a little bit more or much more than the other data transmission methods. The cost of ATM equipment is also very high. Compatible hardware and software may not be widely available. Of course, that's understandable. Now, let's talk about the next transmission method, MPLS and VPN. Now, before we get into that, we need to answer this very important question. Why have frame relays and ATM voice and data delivery networks 2, 3, 5 used so much if internet is available and essentially it is free? I mean, the other ones you have to pay for all of this, but with internet it is free. I mean, why still use these other ones? Now, the first thing is there is no guarantee that the internet will deliver data in a consistent and timely manner, and the internet was not designed to handle data streams with small latency values. The second reason is that the frame relay and the ATMs have been chosen over the internet because of perception that the frame relay and the ATM were more secure. Yeah, I mean, it's a general concept nowadays that the internet is not very secure, but we are going to get into the different ways of making an internet connection secure, which gives it the advantage over ATM and frame relays. Now, despite these apparent shortcomings, more and more businesses are turning away from frame relays and ATM transmission systems and are sending their data over the internet. The internet users now have two new weapons at their arsenal, or in their arsenal: MPLS and VPNs. There are basically two ways a business can create a tunnel through the internet. First, a user installs the necessary software at each end of the tunnel and contracts an internet service provider to create and maintain the tunnel. This typically incurs a monthly charge from the internet service provider, obviously. And the second technique involves the user purchasing the necessary hardware and software that is placed at each end of the tunnel. The hardware is essentially a gateway. Basically, it's an advanced kind of router that provides the necessary VPN and security software. Now, the summary of the difference between high-speed data transfer network technologies. Now, as we can see here, MPLS and VPN is basically the best because it costs the least and it is switchable and fixed, and it is the fastest, although the specific maximum speed is not given on this table. Now, computer telephony integration. We refer to it as CTI. Now, CTI is a field that combines more traditional voice networks with modern computer networks. I mean, before talking about this, in earlier chapters of this course, there is a concept called convergence, and this subject is very important, especially in modern day technology, where in the past we used to have just the telephone lines to transmit just voice signals, and we had different devices to transmit data, but over time they found a way to join these two transmission data together. Now we have new system that can transmit at the same time voice, data, videos, and the rest of it, all of it in one packet, transmitted by the same device through the same network. And all of this is thanks to the concept of convergence, and this concept applies to in computer to telephony integration. Now, CTIs integrate PBX, private branch exchange phone switch, with computer services to create modern voice and data applications that run on computer systems. Traditionally, these services required a PBX switch, a set of telephones, and standard telephony wiring. In contrast, In CTI, all you need is a workstation that is running the appropriate telephony software. Because CTI combines the power of computer systems with the services of a telephone network, a user can perform typical telephone operation just by clicking a button on the Windows program. Now consider the following scenario. A business sells a product and provides customer services to support that product. To obtain customer service, a customer calls the company's toll-free number. Because the company has a CTI system that combines the power of a local area network with the modern telephony system service, the caller's telephone number appears on the screen of the customer service representative's computer monitor as the telephone rings. In bracket, caller ID. Now, before the customer service representative even answers the telephone, the CTI system uses the customer's telephone number as the key to a database query, and a summary of the customer's account also appears on the screen, containing all his details, his name, his location, and his account level, and all the rest of it. And the customer service representative answers the telephone and has the customer information on the screen when the customer says hello. As the representative talks to the customer and learns about the customer's problem, he or she can click icons on the computer screen to transfer the customer call to another party, or put the customer on hold, or retrieve additional information from the database system, and so on. So these are some of the advantages that comes with using a CTR system. Now, using CTR has three more advantages, or main advantages. It creates new voice and data business applications that save company time. It makes optimal use of current resources, and it saves money. Obviously, I mean, it's cheaper to combine two technologies than have two parallel technologies running at the same time. These advantages mean that the business can realize more benefits from CTR applications. For example, unified messaging. Users utilize a simple desktop application to send and receive email. We all do this from day to day. We pay our taxes online. We send our emails through the same network on the same device. And now we can do this on our mobile devices. We can send an email, we can receive voice call, and we can do all of this at the same time. Now, interactive voice response. When a customer calls a company, his or her telephone number is used to extract the customer's record from a corporate database. The customer records are displayed on a service representative's workstation as the representative answers the telephone. The third one is integrated voice recognition and response. A user calling into a company telephone system provides some form of data by speaking into the telephone, and the data query is performed using this spoken information. The fourth one is fax processing and fax back. In fax processing, a fax image that is stored in a LAN server's hard disk can be downloaded over a local area network, converted by a fax card, and sent out to a customer over a trunk. Text to speech and speech to text conversion. Then we have a person speaks into a telephone. The system can digitize the voice and store it on a hard disk drive as a computer data. This system can also perform reverse operation. Of course, third-party call control. Users have the ability to control a call, for example, set a conference call without being a part of it. Yeah, we all do it nowadays. PBX, graphic user interface, call filtering, customized menuing systems, and the like. Now, unified communication. More precisely, unified communication is the convergence of real-time and non-real-time communication systems, such as a telephony, instant messaging, video conferencing, speech recognition, voicemail, email, and something called presence information into a unified interface. Some unified communication products also provide collaborative softwares, allowing teams of users to intercommunicate via multiple platforms. For example, co-workers, vendors, and customers can cooperate and share videos, text, telephony, and images either remotely or in the office. Example, the popular online program Facebook can also be considered as a form of unified communication, as it allows message boards, text-based messaging, online chat rooms, email, and interactive videos all through a common interface. Yeah. Now, this is a very important part of this subject, communication system in action. Now we are going to take a case study. Let's assume we have a company that's trying to make a choice as to which service to go for or to subscribe for. Now let's consider the following scenario. Now, Beta Box Corporation is going to be our case study. This is the company we are trying to investigate. Beta Box Corporation manufactures cardboard boxes. Its administrative headquarters are in Chicago, Illinois, and its regional sales offices in Seattle, San Francisco, and Dallas. Beta Box is expanding its data networking capabilities and has asked for your help in designing a new corporate network. It wants to interconnect all 4 of its locations to the headquarters in Chicago that can accept data records from each of the 3 other offices. Now, typically about 20,000 sales records per day will be uploaded from each of the regional sales offices. Each sale record is 400,000 bytes in size. It should take no longer than 20 seconds to upload a single sales record. Although the company has enough funds to support any possibilities, we may still want to go for that which is the most cost effective and the fastest. These are the choices we have available. We have a plain telephonic system transmitting data at 55 kilobits per second over an analog line. We have a local distance intra-LAN T1 flat monthly rate and a long distance inter-LAN inter-LATA T1 flat monthly rate plus mileage charge. A series frame relay service which include port speed and PVC capacity. A series of ATM services which include port speed, path charge, and channel charge. And we have the MTLS and a VPN to create a secure and fast connection over the internet. Now, making the choice. This is a crucial part. Now, to choose the right data delivery service, you need to choose the appropriate data transmission speed for each service, keep the cost low, and meet Beta Box's requirement. Let us examine the total cost per month that the Beta Box Corporation might pay to a telecommunication carrier to use that service to connect all 4 of its sites. Now remember, let's go detail by detail now. To do a frame relay connection, we need 3 important components: the access line charges, the frame relay port charges, and the PVC charge. For an ATM, we need 4 of these components: the access line charge, the ATM port charges, the PVC channel charge, and the PVC path charge. Now, hypothetically, this is not exactly the table of reference that the engineers in the various companies, telecommunication companies, use as a reference. This is just a hypothetical. We are just going to, this was just created for this example, just for calculation and understanding purposes. Now, assume this is the table we are going to use as a reference for each of the communication service or the type of service. We have the appropriate speed and the per monthly cost. These are just approximated value and it's hypothetical. Remember, this is not the one they use in real life. So now we are going to have to refer to this table every time doing the calculation. Now let's recap exactly what the company wants. These are the requirements of the company. We see the requirement of 400 byte record should be no longer than 20 seconds to upload. This means that 400 bytes times 8 bits per byte, because for every byte there are 8 bits. It means we have to transfer 3,200,000 bits. Now 3,200,000 bits divided by 20 seconds, which is what we don't want to go any longer than this 20 seconds. We give a speed of 160,000 bits per second. We cannot go anywhere below this for the transmission speed. So thus the beta box needs a telecommunication line connecting to the outside world with a transmission speed of at least 160 kilobit per second. So now let's look at the requirements. For a port line, definitely won't survive, because at best it can provide, as we saw before in the details, 53 kilobit per second. So we cannot even go put that into any perspective of calculation, so we forget about that one. The next one is the T1 scenario. Now let's consider the following. Now the beta box will need 3 of these T line, because each of the offices are placed in Seattle, San Francisco and Dallas, and each of these has to be connected to Chicago, and the distances are 2050 miles, 2170 miles and 920 miles. If we do the necessary calculations, before we get to the calculations, let's look at this figure here. Now we have the respective offices, and then we have the headquarters in Chicago, and we are trying to transmit the data over these distances. Now, using the mileage between these points and the 3 interland T1 lines, the cost will be approximated as follows. For the first line between Seattle and Chicago, we have 6,325 at 1,020 per month, $20 per mile for Seattle to this line. These are the rates for each of the lines. For this one, we have this $6,625 for 122.5 per mile from San Francisco to this, and then we have this for Chicago. Now this gives us a total monthly of $16,450. If BetaBox wanted each of these 4 sites to communicate directly, it means we'll have to do 6 lines, because now we'll have to add 2 lines, one from Seattle to San Francisco and the other one from San Francisco to Dallas. This is not cheap. This is very expensive for a company. So let's look at the frame relay connection. Now for the frame relay scenarios, you do not have to worry about running a separate line between each pair of the cities. You only have to make a frame relay connection into the frame relay network, as in the figure on the next slide. Those 4 connections allows us to connect between each of the cities. We don't have to add the 2 extra cities. As we have calculated in the previous one, we will end up with a connection that supports 160 kilobyte transmission. Obviously, a 250 kilobyte frame relay connection is the closest size that will support the desired. You can see in this figure we need 4 of these lines. Now 4 local T1 telephony lines to connect the 4 cities to the frame relay network, which is the main focus, because 4 times $350, which is $1,400. So the total charge for the frame relay would cost $4,490 per month, which is much cheaper than the option for the inter T1 for the Now an ATM solution will be similar to the frame relay solution in that you would only need to have to connect each of the 4 cities to the ATM cloud, and these are the necessary calculations for that. Now for the 4 port charges at the 4 cities, each at 1.5 megabit per second of the ABR, will cost this. 3 channels to support the 3 connections, yes, will cost 3 times $250, a total of this. Now 3 paths to the support the 3 channels, $2 per mile, will cost this, a total of $10,280. 4 intra T1 lines to connect the 4 locations to the ATM cloud will cost 4 times $350, a total of $1,400. So the total cost for using an ABR ATM network will cost $19,430 per month. So our final possibility is created over the internet. Now if you try to use the internet, it's going to give us, we're going to have an initial cost of 1,000 per gateway per port. So we have 4 ports and each costs 1,000, a total of 4,000. A monthly charge from the internet service provider for each of the ports, and each one is $375, a total of 1,500. A monthly charge of the T1 at each of the location of the 4 cities or 4 states, 4 times 350 will give us a total again of 1,400. So it appears that after all of this, we're going to have a 4,000 initial cost, and the total cost will be 2,900 over the internet.